We're on topic 2, and we're going to cover pages 2 to 3. We're going to start off with page 2. Here's page 2, and what we're going to do is we're going to go over the definition of a linear equation. We're going to do the addition and multiplication property as applies to linear equations. So here's the addition property, here's the multiplication property, and finally we're going to solve a simple equation. So that's our objective here on pages 2 and 3. We're going to start, as I said, on page 2. We're breaking this down into 3 parts. So first of all, we're going to look at the definition of a linear equation. This is an equation in one variable. Sometimes we call that an unknown. In this case, an equation in one variable where the variable is x, that we can write as ax plus b equals 0. Now, a and b in this case must be real numbers. They must be on the real number line. This means element of or belonging to. So a and b must be real numbers, and a cannot equal 0. So a and b are real numbers, and a cannot equal 0. So let's take a look at an example of a equation in one variable x. So we write 2x plus 6 equals 0. Here our coefficient of the x, the number in front of the x, is 2. So a is 2 and b is 6. So a is 2 and b is 6. So that's an example of a definition of a one variable linear equation. Another example, here we have 3x minus 7 equals 0. We look up here, the coefficient of x is 3, so a is 3, and this term here, minus 7, is this one over here, so b is minus 7. So these are 2 examples. 2x plus 6 equals 0, 3x minus 7 equals 0. They have the form ax plus b equals 0. Remember that a is always the number in front of the x. In this case, it's 2, and in this case, it's 3. Now, in order to solve equations, we have to be aware of the addition and multiplication property. Let's say, for example, we have the term a equal the term b. If we add c to the left side of this equation, here we're adding c to the left side, so we've got a plus c. Then in order to keep the equality the same, we must add c to the right side of the equation, so we get b, d. So all we're doing is saying what we do to one side of the equation in terms of addition, and this applies to subtraction too, we must do to the other. So we're adding c to the left, then we must add c to the right to maintain the equality. So let's say, for example, I have x equals 4, and in this case I just make c equal to 2, and I'm going to add 2 to the left side of this equation. I'm adding 2 to the left side, so I get x plus 2. Then in order to keep the equation the same, I must add 2 to the right side, and that's why I have 4 plus 2. So x plus 2 is this, 4 plus 2 is 6. So I haven't really changed the equation. This is equivalent to that, and that's the addition property. Let's say I have 3x equal to 7. This represents my a, this represents my b. I'm going to subtract minus 4 from the left side of the equation. In order to keep the equal sign, I must subtract minus 4 from the right side of the equation. So what I do to one side, I must do to the other side. So 3x minus 4 is this, and then 7 minus 4 is 3. So that's the addition property. Now if we go to the multiplication property, we're using the same kind of thing. Instead of for addition, we're going to use this A equals B. If we multiply the left side of the equation by C, we must multiply the right side of the equation by C if we want to keep the equal sign. And C does not equal 0. This little equal sign with a line through it means does not equal 0. C cannot be 0. So let's say I have x equals minus 7. That represents my A equals B. If I multiply the left side of the equation by 4, I got to multiply the right side of the equation. Left side, I mean to the left of the equal sign. This is the left side, and this is the right side. So if I start off with x equals minus 7, and I take c equal to 4, and I multiply the left side by 4, I multiply the right side by 4, the equation hasn't changed. This little dot means minus 7. By the way, we can write this instead of the little dot, we can write it as 4 with a bracket around the x, and instead of the dot here, we can write a bracket around the minus 7. So we get 4x equals to minus 28, and that's equivalent to x equal to minus 7. So what I do to one side of the equation, I have to do to the other side. So let's go over that again. If we have A equals B, we add a term to the left side of the equation. In order to keep the equation the same, we must add that same term to the right side of the equation. I've added plus B to the left and plus C to the left and plus C to the right for addition. I do it for multiplication. What I do to one side of the equation right here, A equals B, I multiply the left side by C, then I must multiply the right side by C. Now we're going to use this information a little later on to solve equations, but let's go over something that we did last time, the review of multiplication rules and distributive property, which we discussed in topic 1. So here we're multiplying plus 6x times minus 5, and the signs are different. So we get, when the signs are different, we get minus 30x. Minus 6, there's an implied plus here in front of the 5. We don't write it in. So minus 6 times plus, again the signs are different, so we get minus 30x. Here we have 6 times 5x. Both the 6 and the 5x are positive, so if the signs are the same, the result is positive. Here we see that this and this are opposite. The signs are different here and here, so the result is always negative. Here we have minus times a minus. The signs are the same. The result is positive. So you've got to remember that when we multiply two numbers together. And we're going to apply this here when we use the distributive property. Here we're going to start off with 2x plus 5, 3x plus 2. So we're going to take the plus 5 and multiply it by the plus 3x. So we've got plus 5 times plus 3x and plus 5 times plus 2. And so we're going to multiply 5 times 3x. We get the 15x. The signs are the same. Plus 5 times plus 2. Right over here we get plus 10. We're going to add the 2x and the 15x. We get 17x, and the 10 is the same. Now what we're going to do is change this same problem and just put a minus here in place of this here. So again, we've got plus 5 times plus 3x right here, and that's going to give us 15x. And here we have plus 5 times minus 2, plus 5 times minus 2. The signs are different, so that gives us minus 10. Here the signs are the same, so we get plus. 2x plus 15x is still 17x, but here we have minus 10 instead of plus 10 because of this minus here. So we're going to again use that. Let's say we have 2x minus 5 times 3x plus 2 in brackets. We do the minus 5 times 3x, which is positive. The signs are different. Minus 5 times 3x by the distributive rule gives us minus 15x because the signs are different. And minus 5 times plus 2 is right over here. And we get minus 10. So 2x minus 15x is minus 13x. And we got the minus 10. So what we've done is change this problem here. So this coefficient number outside is minus 5. And the last problem is, we're going to do two more. 2x minus 5x minus 2. So here we have minus 5 times 3x. That gives me this. And minus 5 times minus 2. So minus and a positive here, when we multiply these two together, it gives us minus 15x. And minus 5 times minus 2 gives us plus 10. So 2x minus 15x gives us minus 13x. And then we have plus 10 over here. Last example, we're going to put a minus in front of the 3x. So when we multiply minus 5 times minus 3x, we get plus 15x right here. Minus 5 times minus 3x gives us plus 15x. And minus 5 times minus 2 gives us plus 10. So we have 2x plus 15x is 17x plus 10. So what we've done is looked at the distributive rule and combined it with multiplication rule in order to remove this bracket here. And we discussed that in topic 1. It's a very basic property, and you should be familiar with the multiplication of two numbers and how you use the distributive rule to remove the bracket. Now we're going to look at an example of an equation and how to solve an equation. The procedure here is isolate the variable x by using the addition and multiplication properties as required. Now what does that mean? We're going to see here we have a basic equation and we want to solve it for x. So what we're going to do is isolate the 4x by itself on the left side of the equation. Okay, we want the 4x alone on the left-hand side of the equation. We don't want this minus 28 here. So if we don't want that minus 28, we're going to add 28 to the left side because the minus 28 and the plus 28 will give me 0. But by the addition property that we just discussed, if I add 28 to the left side of the equation, I have to add 28 to the right. So the only difference between this line and this line is I've added 28 to the left and I've added 28 to the right. And why did I do that? To get rid of, just get 4x by itself on the left side of the equation. So you have 4x by itself on the left side, 0 plus 28. So I've added 28 to each side, and this is called the addition property. And by the way, this fits our form of the equation ax plus b equals 0. A is 4. That's the coefficient of the x. So that's a equals 4. And b here is minus 28. Anyway, so the first thing, as I said, we do is isolate the variable on the left side of the equation. Now, we don't want what 4x is. We want what x is. So what we're going to do is multiply the left side by a quarter, because the 4 here and here will cancel. This is on the denominator, that's on the numerator. And if I multiply the left side by a quarter here, multiply, then I'm got to do the same thing to the right side. And 4 goes into 28, 7. Now, I divide here by 4 or multiply by a quarter. It doesn't matter how you say it. This 4 and this 4 will cancel. So what I'm saying is when we're multiplying a quarter times 4x, what we're doing is doing this. The 4 and this 4 will cancel because one's on the numerator and one's on the denominator, and I'm just going to be left with x. And you can see here, this 4 and that 4 cancel. 1 times x gives me x. 4 goes into 28. And so x equals 7. So what we're saying is, right here, what we're saying here is the only value that will make this equation true, the only value for x that will make this equation true is that x equals 7. That's the only value that will make x equal to when x is equal to 7, then 4x minus 28 equals 0. So that's the only value of x that works for this equation. And you can see that if you go back and check the answer right here, you substitute 4x equal to 7 into 4x minus 28 equals 0. You replace the x with a 7. 4 times 7 is 28. 28 minus 28 gives you 0. And that's what the right side. Now, I prefer to do this a little differently. It's another way of doing it. You check the left side of the equation. And if you go back to the original equation, it's 4x minus 28. So I rewrite 4x minus 28. I replace the x with a 7. 4 times 7 is 28. 28 minus 28 is 0, and the right side is also equal to 0. This is the right side here. This, what I've done here, and what I've done here is essentially the same thing. I've just separated the left and the right side of the equation. Now, it's very important when you're doing these kinds of problems that you do it step by step. Process is very important here. So you have to show what you're doing every step along the way, and so that if you want to go back and check your answer, you at least have a procedure. So first thing we did on this equation was use the addition property to isolate the variable. We want the 4x on the left. Now, implied in that is that we want numbers generally on the right side of the equation. So we got the 4x on the left and the 28 on the right. We want what x is, so we multiply by a quarter here. The 4 and the 4 cancel. The 4 goes into the 28, 7, so x equals 7. Now, we're going to look at page 3, and we have 2 examples on page 3 that we're going to do. We're going to do this one in 2 different ways, and then we're going to show how to do that one right over here. So let's start off with example 1. And we're going to use the distributive property here. We have this equation. Now, remember, we're trying to solve for x here. So first thing we do is multiply 5 times x. We get 5x. And plus 5 times minus 2 gives us minus 10. And the right side is 3x plus 8. So from going from here to here, we just use the distributive property. Now, remember what I said, I want to isolate the variable on the left side. So I don't want this minus 10 on the left side. So I'm going to add 10 to the left side. And then if I add 10 to the left side, I'm going to add 10 to the right side. Because I just want that 5x by itself, because minus 10 and plus 10 will equal 0. So what I do to one side, I've got to do to the other side. So I'm adding 10 to each side. Okay. Now, minus 10 and plus 10 is 0, and here I have 5x by itself. 3x is this 3x. 8 and 10 sum to 18. Now I've got a problem here in that what I have is a variable term here and a variable term here. We do not want a variable term on the right side. We only want it on the left side. So what I'm going to do is subtract minus 3x from the right side. I'm going to do this, and I'm going to do this to the left side. This way, when I add 3x and minus 3x, I'm not going to have any variable term here. I'm only going to have my, in other words, I'm not going to have an x term. And the 3x and the minus 3x will sum to 0, and I'll be left with 18. But now 5x minus 3x is going to give me 2x. So let me go over that again. We've got 5x equals 3x plus 18. We only want a number on the right side of the equation. We don't want this 3x term here on the right side. So I'm going to subtract it out. But if I do that to one side, I've got to do it to the other side. So I've got to subtract 3x from the right side. So 5x minus 3x is 2x. And the 3x and the minus 3x here sum to 0, and I'm only left with 18. Now I'm going to divide this by 2 right here, divide the left side by 2, and what I've got to do is, if I do that to one side, I've got to divide the 18 by 2, so x is 9. So x equals 9 is the solution to this equation. Now, we've always got to, so the key thing here is put the variable term on the left and a number on the right. And that's what we did when we got to here. Variable term on the left, number on the right. So you have to use the addition and subtraction property to finally come up with a variable term on the left and a number term on the right. And you don't have to use just x. You can use another letter instead of x as your variable. Now let's check the answer. We check the answer. We look at the left side. The left side says 5x minus 2. So I write 5x minus 2. Instead of the x, I write 9 because I've got it here. So 9 minus 2 is 7. 5 times 7 is 35. Now I check the right side of the equation. I have 3x plus 8. Replace the x with a 9, which is what I got here again. 3 times 9 is 27. 27 plus 8 equals 35. The left side equals the right side. So this is very important in checking our answer. Now, I'm going to show you a little bit of a quick way of doing something instead of using this addition and subtraction property, which we have used. What we're going to do is imagine that the bridge, we've got a bridge here, here's a bridge, and the bridge represents the equal sign. Whenever there's a crossover, then we just change the sign. For example, if I have on the left-hand side of the equation where I only want a variable, I have a number, I can transfer it to the other side of the bridge or the equation and change the sign. So minus 22 on the left side can be changed to plus 22 on the right side. And similarly, supposing I have 5x on the right side of the equation, And remember, I want the variable only on the left side. If I transfer it over to this side, it becomes minus 5x. So when I change something on one side to another side, I just change the variable. Now let's go back and look at the problem we just did. We said 5 times x is 5x. 5 times minus 2 gives us minus 10. And here we have 3x plus 8. I'm going to change the minus 10 from the left side to the right side. All I have to do is change the sign. And I'm going to change the 3x from the right side to the left side, and it becomes minus. So what I'm doing is, in one step, instead of using the addition property, I'm just going to, when I change something from one side of the equation to the other, I just change the sign. I don't want this minus 10 on the left. I only want the 5x term on the left. I'm going to change it. To the right side, I change the sign. I don't want the 3x on the right side of the equation. I want it on the left, and I get minus 3x here. Change the sign. So that's a quick way of doing it. 5x minus 3x equals 2x. 8 plus 10 is 18. If I divide this by 2 and that by 2, I get the same answer. So let's go over that again. The bridge represents an equal sign. If you want to change places from one side of the bridge to the other, all you have to do is change the sign. So remember, numbers should go on the right side of the equation. So there's a minus 22 on the left side. We change it to the right, we change it to plus 22. If we got a variable that's on the right side and we want to change it to the left side, we just change the sign. The plus goes to the minus. The minus goes to the plus. And that's a quick way of doing that. Now let's take a look at this problem here. Example 2. We have the sum of two consecutive integers is 93. Integers are whole counting numbers, like 6, 22, minus 34. They're whole counting numbers. So if you have to find the integers, why? The sum of two consecutive integers is 93. So if the first one is x, then the one that comes right afterwards is x plus 1, because they're consecutive. Consecutive means they're right after each other. So if we let the first one equal x, then the next one that comes right after it is x plus 1. And so we get x plus 1 equals 93. We remove the brackets here. We get this x is this x is that x, and this is 1. Now I have 2x plus 1 equals 93. So I change this plus 1 from the left to the right, and it becomes minus 1. 93 minus 1 becomes 92. So if 2x equals 92, I divide this by 2, and I get x. I divide the 92 by 2, I get 46. If I go back to the equation, x is 46. 46 plus 1 is 47. 46 and 47 sum to 93. Now you see that what I've done here, I've just broken this down a little further. This here, 2x plus 1 equals 93. I move to plus 1 from the left to the right, and it becomes minus 1. And then 93 minus 1 becomes 2x, becomes 92. 2x equals 92. X is 46. Now I check the left side of this equation is 2x plus 1. 2 times 46 plus 1 is 93. And the right side of the equation is 93. This is the left side. This is the right side. So the left side equals the right side. I know I've got the right answer. So that completes pages 2 and 3 on topic